Hello my friends, today we're going to be looking at nanoparticles. This is a chemistry only or separate sciences only part, and we're going to look at what nanoscience is, why nanoparticles are useful, what they can be used for, and finally a key skill in science, which is how to evaluate ideas in science, which is really common with nanoparticles and their questions in exams. Nanoscience and nanoparticles take into account anything that is in the nanometer range, and 1 nanometer is 1 times 10 to the power of minus 9 meters, or 0.000000001 meters. So it's very, very small. We're talking about a few hundred atoms in size. They're much smaller than what we call fine particles, which are 100 to 2,500 nanometers. Sounds like a weird fact, but it's something in your specification you're supposed to know. And also much smaller than what we call coarse particles, which are also known as dust, which are about 10 micrometers to 250 micrometers in size. So these are things that actually end up being almost the size of cells. So nanoparticles are very tiny structures. They're things that we're creating synthetically, usually, for us to then be able to use. And the reason why they are useful is because as you decrease a structure by a factor of 10 in size, its surface area to volume ratio increases by a factor of 10. So this means that we're getting a very large surface area compared to the volume of the structure. Even if we have the same mass of substance, we've got a much larger surface area if we can use it as nanoparticles, which is the key point. So this high surface area to volume ratio means that they have different properties compared to the larger structures. This means that in chemistry, perhaps they'd be much more reactive. It might also mean that we just need to use smaller quantities of it, because the smaller amount of this drug or smaller amount of the chemical or catalyst or whatever it might be will do the same job as a larger substance and more of it. So it ends up being cheaper. So we're trying to take large molecules and make them smaller and therefore more useful. That's the key aim here in use of nanoparticles. So high surface area to volume ratio. That's what we keep coming back to with why they are useful. They have a high surface area to volume ratio. And this surface area and volume concept comes up again when you look at reactivity, rates of reaction, and the experiments you can do in chemistry. It's a bit later in the course, and it also comes up in biology a little bit too when you're looking at enzymes and how we can increase rates of reaction too. So what can we use these for? Well, there's loads of research that you can do. These are the suggestions from the exam board, and these are just a few kind of ideas as to what we could use them for or what we do use them for already. And the first of all is medicine. And what we use medicine for is actually the delivery of drugs. So either using substances which are very, very small to carry drugs, which then have perhaps a binding site to bind to cells to deliver drugs. So it's nanoscience in the fact that we're using very small structures. In electronics, we can use wearable electronics, perhaps using things like graphene, which is a very small structure, considered to be nanoscience if small enough. In cosmetics, we might have things like anti-aging cream. Again, it is just because of its absorbency, perhaps because it's so small, it's got a high surface area to volume ratio, maybe it works well. In sun cream, perhaps we've got a small enough amount to be effective, but it won't make the white kind of marks on your skin. Simple. Deodorant, perhaps it's got antibacterial action because of the structure being very small. It disrupts bacteria from being able to work, which eliminates some of the smell that would develop. And catalysts, again, we can create small structures which perhaps act as catalysts because of their structure, their small shape. They can actually help reactions work faster. So loads of potential uses here. And what you'll tend to have in terms of questions is firstly, what is nanoscience, and linking it to surface area to volume ratio as to why it works so well. And they might then give you some examples of uses, and you need to then evaluate how nanoparticles can work and why they potentially are very useful. With an evaluation question, this is a typical type of phrasing that you get. So using the information provided and your own knowledge. So it might be a table, it might be a graph, it might be a chunk of text they want you to analyze and take data from. You need to then consider the advantages and the disadvantages of using nanoparticles. They might give you a suggestion, like perhaps it's in medicine, and these example, the table or whatever data is linked to medicine, and you need to then talk about the advantages and disadvantages of that. So when you're answering this, it's probably going to be a 6-mark question. So these 6-mark questions get broken down into levels, and this goes across all 3 of your sciences. So in level 1, it's typically you get marks for having some relevant information. Usually it's using this information that's provided. You can easily get a level 1 answer, so never approach these questions and think, I don't know anything about nanoparticles, I'm not going to write an answer. Always give it a try. Just give some pros and cons from the information you're provided. A level 2 tends to require you to have talked about both advantages and disadvantages, which you must always do anyway. If you do that, you're basically going to get a level 2. To get a high level 2, you need to add in some of your own knowledge, and that's critical. So things like surface area to volume ratio, just roll off your tongue. Nanoparticles, surface area to volume ratio. They have a high surface area to volume ratio, it means they work faster or whatever. And level 3, for level 3, you must add your own knowledge. You must critically use the information provided, and you must add your own conclusion. As soon as you see, and I see this mistake all the time, as soon as you see the evaluate or consider the advantages and disadvantages, it's linked to this idea of something called an evaluation, which basically means you need to look at both sides of whether it's good and bad. It's pros and cons, it's advantages and disadvantages. Should we use it or should we not use it? And with that, you need to write down the information that you have collected from the table, from the graph. You must add in your own information and then put a final statement. I think that this nanoparticles are best in medicine because. I think that they should not be used in medicine because. That's your conclusion. A concluding statement is what they expect of you in a level 3 answer. And you will not get the top level 3 answer if you do not have one. And so many people write answers to these questions and don't include one, even though they've written everything else perfectly. They only get 5 marks out of 6, or maybe even 4 marks out of 6. It's such an easy mark to get by just writing a conclusion to your answer. And that's it for nanoparticles. There's not a lot to it. So remember, the key thing is high surface area to volume ratio because it's so small, and therefore they work very well. And remember some uses. You can go and research some more uses if you want to. Have a look at how they're going to be used in medicine. Quite interesting. And then just remember how to evaluate ideas in science. But thanks for watching, guys. Hope it's been useful. Do like and subscribe, and watch out with the bell for more notifications for any more videos that are coming out. And hopefully it is helping you to learn more about GCSE chemistry and science.